In today's video, we're going to be looking at graphing the absolute value inequality on the xy coordinate plane. And the reason we're graphing on the xy coordinate plane is because we have two variables. We have the variable y and the variable x. So the first thing I'm going to notice here is there's an absolute value happening right here on the right side. So most likely this is going to be an absolute value function, and I know that the function is going to graph as either a V or an upside down V. Before I can graph this, I need to get it to be y equals. So let's go ahead and do the math to have that happen. So when I'm looking here at my inequality, I see that y is right here up at the top. It's being multiplied by -2, and then this quantity is being added, 6 is being added to it. So I need to get the 6 out of there first. So I'm going to subtract 6 from both sides of the inequality. Nothing can go inside this inequality. This inequality is like a jail, so nothing goes inside. So what I have left then, after I subtract 6, is -2y, and then that makes it greater to the absolute value of x minus 2 minus 6. So notice that minus 6 is on the outside. So the next thing we're going to do is we are going to divide by -2, because -2 is being multiplied to y. So now I'm going to divide by -2. I have to divide everything by -2, all terms. So I have to be very careful when I'm dividing by a negative or multiplying by a negative. So right here, so because I'm dividing by a negative number, I have to flip the inequality. Okay, that's very important. So this inequality right here needs to flip because I'm dividing everything on both sides of that inequality by a negative. Okay, so I flip the inequality. This is called an inequality. It's not a sign. Oftentimes people call it a sign. That is wrong. This is a sign. This is an inequality. So your inequality will flip. So then that means what I end up getting is y is less than, now this negative, doesn't matter if it's in the bottom, the middle, or the top. So it's going to be a negative absolute value of x minus 2 over 2, and then I have a negative divided by a negative, which gives me a positive 3. So you can keep it in this form. A little bit more sophisticated is that you understand that this is being multiplied by a -1. So you can see here we have the fraction 1/2. So the other way that I could write that is y is less than, I'm going to put the -1/2, the 2 stays in the bottom because it's in the denominator here, it stays in the denominator there, x minus 2 plus 3. Okay, so we're going to go ahead and graph this without the use of the calculator, and then we will do the calculator. So the first thing that I want to look for is my vertex. So remember, this is my HK that hasn't changed. So that means then that my vertex is 2, opposite of what I see inside, and 3, the same as what I see outside. So I'm going to go 2, and then I'm going to go 3. 1, 2, 3. So that's my vertex. Okay. So because this is negative right here, I know that my V is going to be upside down. And then I also know, because this is between 0, and 1 that I have a compression. So let me just write those little notations here. So here, this means I have a reflection over the x-axis, and this here is where that 0 is less than 1/2 is less than 1, so I know that this follows that rule. So we'd say compression by 1/2. Okay, so remember what I said, because this is an absolute value, it's going to have, it's a piecewise function that has straight lines on either side of the vertex. So we're going to treat this like a slope. This is kind of an easy shortcut way of doing it, and later on I'm going to show you a more sophisticated way of how, if you're given the graph, how to figure out what this is. So let's think of this as a slope of -1/2. So that means that I'm going to start from my vertex, and I'm going to go down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2. And the same on the other side. I'm going to mirror this. I can use the slope only on the right side. Okay? On the left side, I'll have to do the mirror. Down 1, left 2, 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 down 1, left 2. Okay. So now I have to pay attention. There's no equal sign, there's no equal bar here. So that means as far as my line goes, it has to be dashed, because the solution is not on the border here. If we want to think of this as a wall for the function, the wall is not included. So we will have to have a dashed line. Okay. So now the next thing I have to do is I have to shade the region, because it's an inequality. So watch what I'm going to do. This says y is less than. Right here. This says y is less than. Okay? So I'm going to go to my y-axis. I'm going to find my y-intercept. My y-intercept is right here. I'm not going to look at anything else except my y-axis, and I'm going to put my pen on that y-axis, and I'm going to say, where on my y-axis does y get smaller? It gets smaller as I go down. Alright, so I'm going to use this with a highlighter. This gets smaller, my y numbers on my y-axis get smaller as I go down. So that means that everything underneath what I drew in here, everything underneath gets shaded, because that is where y is less than. So we're just going to shade that in. And I do want to point out to you that it does go beyond the graph, because we can't do this forever. It goes beyond the graph. You have to, in order to get a good representation of all the values that y can be, you have to shade it. All of these y's in here and x's in here are part of the solution. Okay. There was one more thing I wanted to tell you. Okay, I can't think of what it is right now. I lost my train of thought. So that is how we graph the solution. To our inequality. Oh, the other thing I wanted to point out to you is if the inequality were the other way, we would then look up. Okay, so the shaded region isn't always inside the V. Sometimes it can be above the V, depending on the problem.